Welcome, everybody. Tonight, we're going to be looking at our final project solution process, basically. And if you guys recall, during our last session, was it the last session or the session before that? Actually, now I'm kind of forgetting. I think it was the session before that. We looked at the final project description, talked through it, and created this text file here, which basically is a pseudocode solution for the programming problem that we see on the screen right here, right? And I'm going to see if I can kind of find a nice way to kind of get both things on the screen at the same time. And this is kind of what we figured out. So what I'm going to do here is I'm going to kind of very quickly look at the instructions, right? I'm not going to read them in detail, right? We're going to create this like student club management thing. It'll pop up a menu where we can add, delete, and edit and list students. By the way, these are what we call the CRUD operations, CURD, which means create, that's add, retrieve, which is list, update, which is edit, and delete, which is destroy, right? So I always like to say it like that. But create, retrieve, update, and destroy. And these are what we call, when we work with information and information systems, that process is kind of fundamental to all of data storage, right? Whether it's in a database or a text file or in memory inside of a list in a program, we're creating information or retrieving information or updating the information, or we are destroying the information. So we call it CRUD, right? So keep that in mind. So really, this application is the first one that we're building where we're doing all of those actions, right? For database and data analytics or AI people, that's a pretty critical thing, because you guys will talk about CRUD operations a lot, I'm sure, in your database classes, but also for programmers, these are very, very typical tasks, right? And you think about it logically, when you have information, you perform those tasks. So add, delete, edit, and list are very, very common. They have examples of what each operation should look like, and we'll try to mimic that as closely as we can. So each one of the menu choices breaks down to these actions, and it's really nice to have screenshots of what it should look like, because then you have something to build towards. And one of the things that we talked about in the pseudocoding process, by the way, is to identify the easiest tasks and complete those first, right? Remember, I suggested that. And often putting stuff on the screen is one of the easiest tasks. So creating the menu, that's pretty easy. I can do that. I can code that for sure, right? So do that, get it out of the way, and proceed in that fashion. Do anything you think is easy, get it to work, cross it off your list, and you feel better about the bigger tasks that you're operating on. There were some minimum requirements, so a program class that runs everything, the main program, a main method, a collection to hold student objects, a menu system, methods for doing all the CRUD operations, and then a student class, which we identified up here, and it indicates here the stuff that we should add, right? Now, and a lot of this stuff, right, we had examples, and I just want to reinforce this, we had examples in all the preceding assignments where we've kind of done all of these operations at one point or another. And in principle, the ideal would be that if I wasn't giving you this guide right here, that you would go back, look at the work you've done, look at it as an example, and use that as a basis for building what we're building here, right? And so you should never feel like you're completely lost, because you really do have a reference in the stuff that we already did, right? And I'm hoping that those of you that did manage to already complete it, that was maybe your pattern of work, or maybe you have enough coding experience, or you've done this before in a different language where you feel emboldened and you can kind of proceed on your own. But it is perfectly normal, and I say this to all the people that are completely fresh to this, to go, I don't know what to do next. That's okay to admit. And what I'm hoping to show you is what is the next and how to break it down. So that was really the whole process of the pseudocode. So all the stuff that we see in the assignment description is transposed then into this pseudocode. And I think I did, an okay job of it. And uh, and the reason I say this to myself is because I looked at my previous pseudocode and I thought I missed a couple of things the last time I did it. So last year's group didn't get quite as good a pseudocode as this year's group, you know. So so I think my pseudocode's pretty darn good. So let's go ahead and get into Visual Studio and let's build this. The last time I did build this, I did decide to create this as one file. So I put the class inside the main program just to have it all in one spot. You can create the class file separately. And what I'm going to do, and this is my typical pattern when I do object-oriented programming, is I think about the classes I need to create first. That's why I put the student class at the top. And I build that because that's like a custom data object that I can pull in. Once that's built, then I can do the rest of the work. That's the way my brain thinks. Not everybody thinks that way, right? So that's my pattern. When I get into the main program, I'll think of all the methods first, like all the, once again, kind of the same approach, what the methods will do. And I might not have all the code for it yet, but I'll build them and maybe leave them empty and then add the stuff as I need it, so that's kind of my build approach. All right. So let's start with the just launching Visual Studio, and let's get it up on screen. We'll go ahead and create a new project here. Same procedure. We're still doing console apps. All right. We'll keep all the top level statements. All right. And then I'm just going to eliminate the pre-existing content here. So that's where the main program is going to be. And then we're going to build an additional class. And what we're going to call it? So if you have good if you have good pseudocode, you can kind of borrow it from there. So this is a student class. I could have said class student, and really there's also this convention, and I really didn't do it here, that when you build a class, that a class starts with a capital letter. And the reason we do that is that then when you look at your code, you can identify student as a class as opposed to a variable, for example, that might start with a lowercase letter. Methods in C# are usually started with capital letters too. In other languages such as Java or in Python for that matter, I usually start method names with lowercase letters and then camel case them or underscore to separate logical words. It's a preference, frankly. Data fields that we need are first name, last name, and email, all strings. Getters and setters for the data fields, piece of cake, right? All right, so let's go ahead and do that. All the data fields, I'm going to make mine all public. I'm going to do string with a question mark, right? Do you guys remember what the point of the question mark was? Go ahead and blurt it out if you wish. You guys don't remember, somebody look it up and then either drop it in the chat. There's a reason for the question mark.
It makes it look like it's not airing out.
Say that again, Sam. I'm sorry.
Oh, I was gonna say it makes it look like it's not airing out.
Yeah, right. Because if I remove this, look at what happens to first name.
Basically, it says that you're allowing that variable to be a null.
Yeah, that's correct, right? And it says, look at the error message. Non-nullable property first name must contain a non-null value when exiting constructor. Consider adding the required modifier or declaring the property as nullable, which is done by putting a question mark here. The question mark is easier, but here's a consideration, right? If it truly is required, and here's where I think where I correlate it to like a database. In a database, if something is required, right, we say not null, and that basically means you have to put that data in, like an ID field or a name or something like that often is in that category. We can think of a class as a custom data object, and maybe that would be a thing to do here. And I'm not going to force you guys to do this, mind you, but I'm just bringing up the topic because, all right, what is the question mark for again? That's what I'm answering the question for you, right? But if something might cause a problem, right, we just put the question mark in and it just kind of inhibits that error message. All right, now it's asking for a constructor, right? So create a constructor with 3 args. Create a 2-string method that prints out properties. Okay. When I came back here, did you guys notice, right? As soon as I was like changing lines, it was actually suggesting that I do a constructor. So I'll do a public. I'll name it the same as the class. And then we're told to do 3 args. I'm doing my curly brackets first so I don't forget, by the way. And what would the args be? Well, the values for first, last name, and email, right? So those are going to be what coming in? Strings. And I'm going to use the same names. I'm going to start with lowercase here. That's what I did last time. Some people will change the name. Some people use the same names. That's not really a good idea, by the way. And a string for email, all lowercase. All right. Then we're going to want to take all these and apply the incoming values to the internal data fields. So I'm just going to very simply do first name equals first name, last name equals last name, email equals email. Thank you, Visual Studio, for doing my typing for me. And more importantly, right, don't think of that as cheating ever. Keeps me from making mistakes. That's how I think of it now. In the old days when IntelliSense was a thing, I'm like, oh my God, that's cheating. You're learning nothing. And then I started thinking about it. I'm like, no. If I was a professional, prevents me from making mistakes and makes me work faster and more accurately. I still have to verify it's correct though, right? So that's the thinking. So there's our constructor. Then we need to do a 2-string method. We've done this a few times too. This will also be public. We need to override the one in the master class. So we're going to put in override. Oh, and it, of course, was doing it already, and I fought it, right? And yeah, 2-string is correct. All right. And it already kind of built it out for me, but I don't want to return from the base class the string method that's already there. I mean, that's kind of silly. So I just need to put together a string here that I can feed in. So I'm going to do a string interpolation. So $, to start, set of double quotes. And then what are we sending back? Well, the 2-string method is going to put the first name, last name, and if you look at the example, it'll output a pipe, first name, last name, a pipe. That's what that's called. And then the email address. The pipe is the shift of the / key right above your enter key typically. So here's my pre-constructed string. Yes, I am copy pasting. Right. Now, if I look at my pseudocode, student class is done, right? Student class, data fields, done, getters and setters, instructor with 3 args, 2-string method that prints out the properties, all good. Right. And notice, right, look, it's like a grocery list. So I got that part crossed off. Right? Got the milk, the eggs, butter, and the sugar. And it's encouraging when you can cross stuff off the list. And this is why a to-do list is helpful and why pseudocode is helpful. Right? If only to encourage you, really, truly. And I say that kind of facetiously, but not really. Right. I'm going to do a Control S to save. And okay, I'm doing it in Notepad. Really, I want to do it here in Visual Studio. Control S to save. Once again, this class declaration, I'm putting it inside the program file just for simplicity because it is a really simple class when all is said and done. What is it doing? It's just containing the data and allowing us to get and set the data and pull the data back. That's all this class is doing. I think Kelvin, you keep getting dropped out and coming back, aren't you?
Sorry about that. I
No,
just
it's okay.
my Mac.
You're either having mac and cheese or you're using your Mac. Is that what you're saying?
I said I'm using Mac. I'm also eating dinner too, though.
Okay. And is it mac and cheese?
No, it's tacos.
No, but you know what? Mac and cheese sounds like a good dinner to me tonight for sure. All right. Yeah, that's getting recorded in the video, by the way, Kelvin. So everybody knows that you're eating dinner and on a Mac. The whole world now knows. Let's go to our main program body now, and I have a set of notes there. All right, and you know, for as goofy as it is, you know, sometimes when I pseudocode like this, I will do goofy things like this where I put little like dashes in front so I know I completed it. I'm not going to do that here. I'm going to try to work my way down and we'll see if it works that way. All right, so in the main program, we decided that we need to pre-create a list of student objects, a variable to hold menu choices, and create a display menu function, or you know, or method, I guess you could call it. And that could be down here. So amongst these things, and I didn't do that last time, right? But display menu, or either that or I have to hard code the menu each time. We'll figure that out. All right, let's do the first task, which is to create a list of student objects. And I put in a note that it could be global. Now I'm looking at my old solution here. Is that what I did last time? All right, I made it global. I made it global to the main method. So I actually put that here is where I put it. That's kind of interesting. All right, so that'll work there for sure, but it also could be put here, you know, so that, and you can have a discussion about what makes the most sense. If I put it in the main program body here, and then I make a bunch of function calls here to functions that will reside down here, will the functions or methods down here be able to access the data object here? Okay. Caleb's nodding, and it sounds like a voice of experience, you know, but we could also put it up here. It is possible to put it up there as well, but I think this is actually the more logical place. That's what I did last time. So I created the list of student objects basically like this, right? And this is where IntelliSense helps, right? You know, so I can create a list, right? Okay, it's suggesting a string, but that's not what I want to do. I want to create a student object. I'll call it students. We'll create a new one that calls the default constructor, and it builds a new list of empty student objects. It's an empty list. It's not filled with student objects yet until we create them, but this is just a list that will hold students with these data pieces inside of it. All right. So that's a good place to put it. The other thing that we need to create is a variable to hold menu choices from the user. And once again, I say global or main. So I'm going to put that here also. And what I called it last time was just option. You know, that's so like you put the menu up and the user chooses the option. So that's where we're going to put it. What are they going to be putting in? A number? Do I want to pre-populate this with a value? Well, it depends on how I write the loop that's going to run the program, because I could write a while loop until they choose to exit. And then what value would I put in there? I don't want to pre-populate a menu choice, and I don't want to put the exit one in there because then it'll exit right away. So I'm just going to leave it empty. It's uncomfortable to have an underline, but it's a green underline, not a red underline. Right. I'm going to get rid of this comment here. So we have our container for student objects, and then we have a variable to hold the menu choice. All right. What I had next then was a while loop to run this until they choose to exit. And then, so I could do a while loop where I test the condition first, or I could do a do while loop that runs the code once and then checks the condition. And I don't know if you guys remember, we tried both approaches, and there's neither a right or wrong. But if I do a regular while loop where I could check a condition first, then I would need to set option to something to keep it from failing. So my brain, and the last time I did this, I ended up doing a do while loop instead. So if you did a while loop and you already did this, great, right? But here I have to set a condition at the end that would get it to exit. Now, if we look at the example, right, the regular menu is 1, 2, 3, 4, 5. 5 is exit. So if the exit command is 5, I want to run this loop until the option does not equal, or I want to run the loop as long as the option does not equal 5. If it does equal 5, then we pop out. That's the thinking. So this statement then, instead of just being set to true, I'm going to say option does not equal 5. Okay. Now, right now, this is flagging red because right now the value is unassigned. We will take care of that. Okay. All right. The first command inside here would then be to display menu. And yeah, I'm typing in a function that doesn't exist. And why? Because now I want to create it. And I'm going to use this approach, which is create a method called display menu. And then we'll tweak its settings. All right. Should it be private or public? Doesn't matter, right? This is going to be internal to this program. May as well leave it private. Is it going to return a value to the screen? Well, it's going to put stuff on the screen, but it's not really returning like a piece of information. So static void is actually okay, right? What we want to do then is just basically write the code that's going to display the menu. So here's where we look at the example. So we need a line that says student club management, and then we need these lines: add student, delete student, edit student, blah, 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 blah. These are all numbered. Should I hard code these? Yeah, I'm going to hard code the numbers, right? I'm not going to pull those from a list or anything. And so I'm basically going to create exactly what I see on the screen here. And so I'm going to go ahead and, yeah, I have it all typed out already. You guys might, but this is how I did it last time. I did a right line student club management, and then I put the 4 menu options or 5 menu options with line breaks. So I could have done a bunch of console write lines, like, 5 separate ones for each menu item. I just did it all in one. Doesn't matter. It'll end up on the screen just fine. And then we have a prompt to have the user select an option. Okay. So that will display, this is just displaying the menu, right? Back up in the main program, though, when we receive that, we want to process it, right? And capture that. And we've learned a couple of approaches now, but if you go back to the, was it the module 7 lab, where I taught you the try parse technique, that's the technique that I'm going to use, right? And you could do it the old fashioned, like regular console read line, put it in a variable and then move on. But I'm going to use the try parse. And this is what I did. and I'll walk through the syntax of this again, right? So we will try parsing what the user types at the console. And parsing, remember that term means to read through the text, is basically what it means. And if I can read something in that happens to convert to an integer, I will output to that variable, whatever that is. That's how the statement functions. So really, try parse, right? So now you guys know object-oriented programming is a method of the integer class. You see that, right? And its job is to, well, what are we parsing? Whatever's coming in from the read line, and then we're outputting to the variable that exists hopefully somewhere in the program in the form of an integer, whatever was typed in. But if they type a word, this won't work. It'll be invalid, right? And so we're going to have to deal with that falseness, basically. And then we can move on with the program. So we display the menu, and then we do the try parse. Now, what some people will say is, well, could you put the try parse here? Yeah, you could put it here if you want. And then it would actually be returning something. And what would it be returning? A variable. And then the try parse approach becomes kind of silly in a sense. But would it be returning it? If I put that statement inside here, would it still work? You know, it's the question you ask. Here's how you find out. Just try it. You know, I'm going to do it like this, but I could also put it in there. You know what? Remind me to try it, and we'll try it as we kind of roll forward. All right. So there, now we have captured the choice from the user. And then now we have two options, right? Because now we have to check that choice or option from the user. And then depending on the option they chose, run the right code, right? So we could use a if statement, or we could use a switch case. I went with the switch case. And here's my thinking on this, right? It's not like we're checking a value that might vary. It's really going to be a fixed selection of choices. And I think in that situation, a switch case is really a better choice than an if statement. Either one would work, though. There's no right or wrong. It's just a matter of which you choose. I can engineer either one to work, just like I could make a while loop work instead of a do while loop. It's just a choice. So here I'm going to choose to do a switch. Option will be the thing I put in there, and I'll close my curly brackets right away on purpose. Why? So I don't forget, right? And then we just need to set up our cases. So there's going to be a case if they type the number 1, right? And what happens then? Okay, well here, this is what's kind of fun about this, right? Display the menu, capture the user's choice, check to see if the choice is valid. Here's kind of the interesting part. This is all handled by that one statement, right? And we've learned this in the last unit. All right. If not valid, ask to re-enter. All right. Where am I going to ask them to re-enter it? I'm going to do that in the switch case statement. That'll be my default if none of the cases hit, right? I'll just say invalid input and make them go back through the loop, right? So, you know, and in fact, if it makes you feel more comfortable, right? And sometimes, you know, people want to have that in place already. I can just put in my default right away and say console right line invalid input. And you can say try again if you want, but I'm just going to say invalid input. I think that's really enough. And then you would break out. And when you break out, you just go through the loop again. And you display the menu, see if it's valid. If it's not valid, you say invalid input. And you just put them back you just keep putting them back in the menu. You know, so it's really kind of a very simplistic, but also elegant way to kind of handle the issue. All right. But if we do case 1, well, case 1 is to add a student. So we're going to create add student. That's going to be a method, right? And I want you to watch what I do here. It's going to be uncomfortable having like red underlines in our program, but I'm going to go ahead and I'm going to take these and just build the structure of the switch case statement first, name the methods we're going to have, and then build each one at a time, right? And once again, that might be uncomfortable for some of you because it's like, well, then I can't test things. And yeah, that's true. You can't test things along the way. So maybe you can comment them out if you want, or you can build the methods and just put a pass statement inside of them until you actually do it, right? So that's actually the approach I'm going to take. Right? So we'll have a delete student, and you just go through that process, right? And here's, by the way, yeah, I'm copy pasting for speed, so we're not here all night, but I'm going to do a case 3 to edit students, and yeah, we're going to pass a student object in to do that, and then to list the students, and we're going to pass the student object in to do that. And then number 5 will be they want to exit, so we say goodbye or so long or whatever you want to say, sayonara. All right, let's go ahead then. The one other thing that I did, and I did this more for beautification of output, is I put in a console write line here just to have a blank line between iterations. So there's my switch case statement. And folks, that's the main program body already, the whole thing. Right. I want you to notice that when we look at the pseudocode, right? So if the choice is valid, right, that's already handled by try-parse. Run the correct code to match their option, switch case, right? If they choose to exit, got that handled. And then redisplay the menu. So maybe that pseudocode doesn't really quite make sense. We redisplay the menu if they choose not to exit. And really what this should say here is else redisplay the menu. Yeah, that's more logical to what's really happening. And you see I'm tweaking my pseudocode as I go. It's kind of like I have the blueprint for my house and I'm like, oops, they forgot to put a roof on the garage. Okay, well, I guess let's put a roof on the garage then. Right. You can change the blueprint, we haven't really built everything yet. All right. Now let's go through the process of building all of the methods. And then initially we'll just put in a pass statement just so they don't throw errors, right? So I'm going to use the easy approach. I'm going to hover, show potential fixes, right? Generate method, add student. Okay, there it is. What am I going to put inside here? Well, actually, honestly, I could put it in pass, but I just have a thing here that doesn't throw an exception. That got rid of the underline too. I'm just going to leave it. Right, and then we'll come back and tweak it. So let's do that for all of them. Quick actions in refactoring. This time I'm doing it with a right click. Generate method. Right click. Generate method. Right click. Generate method. Right, so all the methods are built. Now we're going to populate them, but all the underlines are gone. So now, as primitive as it is, what does this program do so far? It'll put a menu on the screen, accept my option, and then not run any code. Basically, it's what it does. Could I test it at this point? Yes, let's do it. All right, so I'm going to run it. And let's see what happens. Now, this is a concept I haven't talked about a lot, but sometimes when we build a piece of software, and even though it doesn't really do anything yet, we reach a point where we have something built, maybe it's just a menu, and we just run it. And what happens in the background, and I wouldn't call this exactly a clean build, but usually this is what we call it, a clean build. We build the code, and at least we have a starting point. Like this works. The menu works. Yay. And we take our little victory and go with it. But then when you get an error later and it says you want to run the last code that worked, it's like probably not, but at least we had code that worked at one point, right? So I can, for example, type in an 8, just puts the menu on the screen. I can type in a letter, puts the menu on the screen. I can put in a 4. Well, that throws an exception. Okay, that's not good. But I could just as well put in a 5 and that actually exits. Okay. So right now, all the methods here would, so this would crash your program. If I had a pass statement in there, it wouldn't, but whatever. I know well enough not to run that code. All right. But here's the other little takeaway that I'll show you here is notice how the main program body really is very, very simplistic. And what happens there is it's kind of like the control panel, for a complicated machine. Like you sit in a car and you call for heat or heated seats, which is very nice this time of year. And once again, you don't care what the mechanism is, you just care that it works. And here's the button for it. And I'm going to press, add student, and it's going to add me a student. All right, now we got to engineer each piece. All right, thank goodness for pseudocode because I have that all written out already, right? So we've completed all this already, right? Now we're just going to build each method and we're going to go one at a time. The thing that I ask at this point, right, is which of these is the easiest of all of these methods? And we talked about this last time. Which one's the easiest, do you think?
List.
Yep. Just putting the names on the screen is a good one, right? One problem that we have is, well, if there's no names, I can't put any on the screen. So I'm going to build list and then I'm going to build add to test it. But listing the students, it really truly is the easiest of all the tasks. So let's go ahead and build that one first, right? Just happens to be up here at the top because of the order that we built them. And so what would that look like? Well, here we have an example to draw from, but basically is, okay, they selected the option, it was number 4, right? And then we just number them, first name, last name, email. What method in our class structure takes care of that? To string, piece of cake, right? So very, very easy to accomplish. But there's also this scenario, and maybe we didn't think about this, and maybe I did think about it. Let me see. List students. So let me just pull this over a little bit. Print all the students in the list of the console. Display numbered list of students with 2 string for each student. Numbers can be generated from index position +1 because the first index position is 0, right? And then when you're done, go back to the menu. There's something, because I'm looking at my code here and there's something I didn't think about though. What if there's no students? Aha. All right, so there's a pseudocode piece I didn't think about. So here I am altering my code again. I'm going to say if student list is not empty, then display the students, right? Else, or maybe I'm doing this backwards, and I'm looking at my code. Last time I said if, how about if the student list is empty, then what do we do? Display an error message, because that's where we're going to start, right? This is why I'm kind of going there. Else, display a numbered list of students, and then go back to the menu. That's a little better, right? All right. So let's code this part of it. So it looks like we need an if else in here. So I'm going to say and I'm only doing this because I did it last time, so it must be kind of an appearance thing. The first thing I did inside of here actually was a console write line, blank line to start with. Then I did the if statement. I said if, I'll zoom in a little bit to make it a little easier for you guys to read. If the students, oh, done. TeleSense is failing me. All right. So if the students list is empty, and I would know that because I could use the count property to check it. If that count is equivalent to 0, then I will console write line my error message, which is going to be what? What should the error message be? I'll do a blank line, and then I'll say student list is empty. Okay. That's what I'm going to do. Student list is empty. Else, what happens? Well, I already have that in pseudocode. My pseudocode says, else display a numbered list of students with toString for each student. All right, that's nice. Those are words, but how do I make that happen? Well, if you look back at some of our previous list endeavors, we need to go into the list of students, one student object at a time, and then run the toString method for that. And if I have one student, it happens once. Okay, that's easy enough. But there might be multiple students. So that sounds like a repeating process, right? Or a loop. So I'm going to do this with the for loop, and I'm going to set up a for loop. So I'm going to set up a counter starting at 0 because our index number starts at 0. And then if I stays less than the student count, right? That makes sense. And we increment by 1 each time. I am going to close the curly bracket here, though. And I don't actually, do I need curly brackets here at all? You know what? I don't think so. I think it's going to be one statement. Here, I'm just going to console write line as follows. So watch what we do here. So I'm going to console write line the number plus 1. We start at 0, so we're going to add 1 to it because the first one's going to be number 1. A little period there. And then the student in the current position, start at position 0. And when I do this, this will automatically call the toString method and just put the stuff on the screen. That's the beauty of the toString. I don't have to format it. It's already formatted. Okay. Anything else I need to do in here? Nope, go back. Once this is done, it'll go back to the menu. That's my pseudocode. Okay, one method is done. All right. As goofy as it is, I'm going to test it even though it's empty. Right, so here comes the runtime, right? List students, 4. Student list is empty. Okay, I believe you, right? Because I didn't put anything in there, so I'm going to exit. But at least that part works. Now I got to test the other part of it very simply by, I got to build add student, and that would go next. So let's take a look at our pseudocode for add student. So, all right. Prompt for first name, prompt for last name, prompt for email, capture the data. So we'll put those all in variables. Call the constructor, send the capture data to the constructor to make the object, add the student object to the list, and go back to the menu. Does any of that sound hard to you guys? It really isn't, right? All right. So let's go to add student. So we're going to go here. Once again, I'm going to start with a blank line. Why? Because I did it last time and it made it look nice, basically. One blank line in there. And then we'll prompt. Here's the first prompt. Enter the first name. I'm going to save it in a variable called first. enter the last name, enter the email. So storing them in first, last, and email, all lowercase, only exist inside this method. Then we're going to call our constructor. So I can do this a few different ways. But when I add stuff to the list, you guys remember what method adds stuff to a list? Yeah, it's called add, right? You can go back and look that up. But I'm just going to say students, that's our student list. Oh, no, not list students. Students, lowercase. I type it correctly. Dot. Okay, so it keeps like, okay. Not liking it. Why is it not finding it? Oh, here's why it's not finding it. All right, watch this little weirdness. If I make this global, so here's an argument for making it global. Now the method can access it directly. And so if I say students, still wants to do that. Very interesting. So it's not seeing it. So making it global doesn't make it do that. But we did call it students. So it doesn't have to be global, but I'm just trying to prove this point to you, right? That doesn't have to be there. So I have to force the syntax here because I'm not really doing a method. And this is where IntelliSense fights you a little bit. But I'm going to use the add method, and then I'm going to build a constructor inside of here. The constructor is simply, now I'm going to say new student, right? Capital STU, new student. And the parameters going in will be first, last, and email in that order. And notice, right? It's auto-suggesting. That's not how I want to do it, but that's the data it's expecting is string, string, string. So I'm going to send in first, last, and email. Just like that. We have this goofy error message. What is the problem? Why is it not seeing the student object? Well, here's the answer. When I am adding a student, right? Am I dealing with data? This is the question you should ask yourself. Yes, I'm dealing with data. What data am I dealing with? Well, I'm dealing with this list of student objects. So when I'm calling it from here, I need to pass students down to that method so that I can manipulate the data inside the object. Otherwise, it's never going to see it. But now it's got a problem again because, okay, you're sending the object down there, but now students doesn't have, or add student doesn't have a way to receive that. So here I have to tell it what type of data that we're receiving and what kind of data are we receiving. Okay. If your brain says a list of student objects, you are correct. So I got to tell it what kind of data are we receiving. It's a list of type student, right? And what are we going to call it here? Well, we can call it a number of different things, but you could just call it students if you wish. That's okay to call it the same thing. So we're sending that list of students in. Now notice the underlines go away, right? Now it's okay with first, last, and email. What's this little underline all about? Oh, what do we miss? Oh yeah, one more parenthesis. There we go. Right. First parenthesis is for this is for the constructor. That's for add, right? Open and close. All right. So now when we add a student, notice they have a little message at the end that says student added successfully. All right, let's add a console write line that does that. And I think that's a good thing because, okay, I typed in some data. Did it work? it's kind of nice for when it says, yeah, it worked. Okay, student got it successfully. Oh, here's the beauty. Now we can run it, we can add a student, and we can list it. Yay, right. So we're working on the C of CRUD, which is to create, right? And then the R of CRUD, which is to retrieve. So let's do that. So well, if I try to list students, it's empty, right? So now I can add, and now it enters a prompt. Okay, so I'll just put myself in. Okay, said it added it successfully. How do I know? Well, I got to list it again. So I'm going to type 4, and there I am. Let's add another. Okay, so we'll add another student. And I don't know. Now I'm making up names. List. Okay, it's working. Now I want to get the heck out of here. So I'm going to type 5, and we made a clean exit. Okay, so there's an example of add student being completed. All right. Now, okay, so I picked up on the fact that if I'm going to add a student, I'm sending students. If I'm deleting a student, do I want to send student? Yeah, I'm gonna be sending the students for all of these, right? Now this one's flagging a problem, so that one I have to also add the list of students to delete. But you notice the others didn't give me that error because when I pasted these in, I told it to send a student object. So when I built the method, it automatically accepted the object. Isn't that cool? So if you know what parameters you're going to pass, and then you do the right click, generate the method, and the right data type is in the parameter list already, and then it builds it correctly. Right, so just a couple little tips and tricks for working with Visual Studio, basically. All right, so we got 2 of the methods built, add and list. I'd say the next easiest one to build is remove, and then we'll leave edit for the end because that's got a little bit more work to it. Okay, so here it says display a numbered list of students. Okay, so remove student will start by listing students, because how else do you know what to remove, right? Okay, so let's make that happen. All right, so let's go back here to Visual Studio. I'm going to go to delete. And I already said first task is to just list the students. So could I just call the other method? Yeah, I could just call the other method and say, list the students, please. Which students? The ones in the student list. Same function call I had up in the switch statement. All right. Then we're going to ask, okay, what student are you going to delete? Blank line, what student are you going to delete? And we want the number. So I'm saying to enter number to delete. Okay. Then we'll capture the info. We're going to use try parse again. We can use the same statement. Yeah, do I need, okay, why did I do that? Do I need this here? I don't think so. Okay, oh, interesting. Okay. Oh, right, it needs it there. Okay, because we're going to use it inside the method here. That's the why. So now we got to think about the logic for deleting. Okay, prompt the user to remove, capture data, make sure selection is valid. Okay, so if it's valid, remove from the list. So we got to figure out how to do that. How do we remove somebody from a list. Okay, this is when you go back to um, your lecture materials and look it up. And how are we deleting somebody from a list? There is an option to remove, right? There were a few, and I want you to think about this. There were a few different ways to do it. I can just do a remove, or I can remove from a certain position. And notice they're going to type in a number, right? Which student do you want to remove? Student number 2, right? And then we're going to remove at. So there's a method called remove at, and we can pick the position, and it's going to be whatever number they typed in minus 1 to accommodate for the index number change, right? So, all right, here's the first part of the logic. Just did an if statement. I'm like, if the option is less than or equal to 0, that doesn't work. So that's invalid, by the way. Or if the option is greater than the student count, so one number higher than the last index number, it's invalid. So I'm going to say invalid student number. Right. Yeah, and then we're going to do an else, but we're not going to do a right line right away. Else, and this part is going to need curlies because it's going to have more than one statement here. I'm just going to do the removal. So here's a removal command. So I'm going to take the student list. I'm going to remove at a certain position in the list. Really, and what goes here is the index value, but the option number is 1 higher than the index value. So option minus 1. And it'll go right to that spot in the list and remove that index position. Right. And then what happens with the list, right? If I remove somebody in the middle of the list, the ones that follow will slide into that position. So if I remove position 2, what was in position 3 afterwards will now be position 2. So we remove at that position, right? And then we should have a little message letting people know that it actually worked. So here's the little console right line. And delete is now complete. All right, let's save that. Let's try it. So, okay, in order to delete students, we have to add some. So I'm going to add, and once again, I'll do myself. Let's add another student. Let's add one more. Let's take a look at them. So I'm typing number 4. Now I'm going to choose to delete. So I'm going to choose option number 2. It gives me a list. Enter the number to delete. I'm going to delete Joe. So it's going to subtract 1 because Joe's in position 1, not position 2. And now I need to prove that it worked. So I'm going to do a list. Joe's gone. Jane's now in position 2. Now I can delete myself. I can list again. Oops, L doesn't work. 4 works. Then if I want, I can also delete again, and I can delete Jane this time. And then when I list, 4, sorry, list is empty. Okay, we're good. And I can exit. All right, so we have almost all the commands working now. We have one command left. So we're going to finish that command. I know we're overdue for a break. We're going to finish the command, and then we'll take a break, and then we'll come back and do that quiz thing. All right, so let's look at the last one, which is to edit students. So we're going to come down here to edit, wherever the heck that is. It's way right here. And then we'll confer with our pseudocode again. All right, so edit. All right, display a numbered list of students. Okay, that's easy. Prompt the user to choose student to edit. Okay, we kind of just did that. Make sure it's valid. Okay, and then if valid, we prompt to change each one of the names, capture data. We've done that before too, right? Apply the changes to the object. So that will be probably different syntax. Display completion message and go back to menu. But you notice how like you get to the one that seemingly was the most complex, and all of a sudden it's like, well, we did that. We've done that, right? Oh, the only thing that we really haven't done is this. So you see how like now the task that seemed the hardest actually is like, oh, there's only one new thing inside of it, really. So, and you know, this is the power both of pseudocoding and kind of thinking through things first. So once again, we're going to start here by doing the listing of students. So I'm going to delete this, and then, well, hey, could I do this? Can I copy all of that? Yeah, I think so. So we'll list the students, enter number to edit, right? Instead of delete. Capture their choice, make sure it's valid. I'll put it as an integer. And then we run our logic. And if I remember right, our logic was check to see if it's valid. So let's just do if. Okay, well, you know what? Could I use the same logic I used here? I just do this. Yeah, totally. Same logic. No difference. Okay, so what happens if it's not valid? Well, same thing. Invalid student number. All right. Then we'll put in our else. The else is going to have a few more steps. So curlies. All right. I know that in the pseudocode I do this. This is kind of interesting. I say prompt to change first name, last name, and whatever. Could I just do it the same way I did it before? I mean, I already have the prompts, right? So like if I look at add student here, where's add student? Add student, right? I'm prompting and I'm putting the stuff in a string directly. Right. And then I use those strings to build a new object, but that's not what I'm doing here. So there's a little bit of a wrinkle, right, in dealing with this. Because when I prompt here, I'm storing temporarily and then building a new object with it. But in edit, I'm going to prompt, and then I want to take just the part of the object that I want to change and change it. So for example, if, you know, like this happens with females often, right? They get married and then they take their husband's name, right? I don't want to change her first name and I don't want to change her email. Well, I probably want to change her email, right? But I want to change her last name, but not their first name. So I can just change the first name or the last name and just change that part of the object. Now, mind you, I'm passing in an object, right? So in order to just change part of the object that I'm receiving in here, I might want to create it. So here's my approach here. I'm going to actually build a new student object temporarily. So I'm just going to call it temp, right? And I'm actually going to accept this code. So I'm going to read in the object from here, put it here, choose the particular one in the list I want to use. But remember, whatever the one in the list is, I'm subtracting one to go to the right index position. And then I'm putting that object that I'm pulling out of the list here in a temporary object, right? Now I want you to remember that, and this is an important teaching point. When I copy an object in memory, what happens is both of them are pointing to the same position. So this temporary one, if I change the first name in temp, it's also changing the first name in the student list above, because they're both pointing to the same spot in memory. It's a reference. This is kind of an interesting thing. We're not really making a new copy. We're still pointing to the same spot. We're just using a different name to do it. Right? And that, I don't know if you guys remember that stuff from the lecture or what it means, but you can test it if you wish. All right. So then we get to the prompts, and then we just kind of repeat the prompts we had before. So we're going to do this. Enter a new first name. It's going to write to the temporary object, whatever we put in there. But notice, we're changing the first name directly. We can do that because it's got a getter and a setter. So I just treat it like a variable. Okay. Then we follow the same technique for email and last name. Same exact approach. Directly changing the property with whatever was typed at the read line. We assume what they type is correct. All right. Then that's all it takes. That's it. And then a message. And we are done, folks. This is the whole application now, and it will be working. So this is edit student on the screen there for a moment for those coding this. All right. I'm going to go ahead and hit the run. Now we're going to test the whole darn thing. All right. Move this over to the side so you can still copy code. All right, let's add some people. I'm going to add at least like 3 or 4. I'll stick with the names that I've been using. And let's add one more. Let's list them. Oh, invalid input. I keep hitting L for list, so maybe I should code it that way, right? Okay, there's my list. All right, let's delete one. Who are we going to get rid of? Looks like I have to go. Let's list it again to make sure. Oh, keep it an L. All right. There we go. I'm gone. Now we want to edit the students, which is 3. Who are we going to edit? Jane. Jane got married to Joe. So new first name, not going to type anything. New last name, Smith. New email address. All right. Let's list students. Type an L again. All right. Now I'm typing a number 8. Now I'm typing a -1. Right. All of them are invalid. But let's type a 4 to see the list. And there we go. Uh-oh. Not good. Right. So if I don't want to change Jane's first name and email, I better type, we got to type the information back in. Now, if you guys want to take this really down a complicated path, right, you could do this. I could add if statements here, right? For example, and if I said if the read line here is blank, don't change. You don't change it, right? So I could write an if statement to accommodate that. But at this point, real frankly, I think what is probably the smarter move is that now that I see that I broke Jane's name, I should go in and 3 edit edit number 2 and just fix it, right? So Jane Smith and J, right? Because now she has a new email address too, right? Changing the last name. Although, I think about that when I have female students that get married and they change their last name, often they stick with the same email address because they don't want to change their email, right? And now let's list it again. Okay, now she's fixed, married to Joe. And then that Monty Python character, he's got to go, right? So we'll get rid of number 3. We'll list the students again. All right. And you know what? I think we're ready to exit. We have a working application, folks. But, the only wrinkle I would put in, right, is maybe we could type an if statement that if they press enter at one of those prompts, it doesn't change a thing. Right? That wouldn't be that hard to code. But let's call that a solution, right? And this video is complete.